Hello. Today we're looking at EGR systems and methods of testing them. This is a 2-litre engine that we're working with, PSA, using common rail system produced by Bosch. There are many methods of testing EGR. You can look at results from code readers, you can look at results from vacuum gauges, you can look at results from the use of a vacuum pump or a pressure pump, and you can look at results from multimeters. You should, of course, look at results from as many different areas as you possibly can. We will also be using a gas analyzer specially designed to work with diesels so that we can see exactly what an EGR does. This 5-gas analyzer has the ability to be able to examine all the 5 gases that you would normally examine on a petrol engine. That's CO, CO2, HC, NOx and oxygen. But of course the gases from the engine have to be first specially treated so that the particulates from the diesel engine don't destroy the gas analyzer. That's why this is specially designed for the job. First thing we have to do is, of course, turn the machine on. Here we have the 5 gases: CO, CO2, hydrocarbon, HC, and O2, oxygen. This is reading fresh air at the moment. The 5th gas, and most important to, when diagnosing diesels, is NO, NOx, oxides of nitrogen. Now, before we go too far into testing EGR, we ought to really know exactly what it's there for. It's there to recirculate exhaust gases. Why would you want to put exhaust gases back into the inlet manifold? It's an interesting question, and it's not necessarily immediately obvious. It isn't to warm the manifold up, it's actually to try and reduce internal cylinder temperature. The idea is, if you reduce the amount of oxygen coming into the engine and put in a relatively cold gas, and the exhaust gas by the time it gets back to the inlet manifold is relatively cold, then you will absorb more temperature from the burning gas and help transfer more energy to the top of the piston, but you will also reduce burn temperature. Why would you want to reduce burn temperature? Particularly on a diesel, it doesn't make sense. Well, actually it does. Internal of a diesel engine, localized temperatures can get very hot indeed. Nitrogen, of which there is a very high percentage in the air, loves it when it gets hot and is subjected to pressure. Then you end up with NOx, and NOx is not a nice gas to have. So here we have some results on a running engine. As you can see, CO level, 0.13. That's actually quite high for a diesel. I would have expected that to be below 0.1. Hydrocarbon level, now that's actually very high. That's 18 at the moment. For a diesel, that is quite high. I'll explain in a minute. NOx, 38, it's very low. Oxygen level, 15.05. That suggests to me the EGR is actually open, and I'll prove that in a minute. CO2, 4.2. That's fine. My worry is the HC level. And see if the NOx level changes when I pull the vacuum pipe off the vacuum actuator of the EGR. The vacuum pipe's now off, and we expect this to go up and actually the oxygen level to go up. Because we're no longer circulating any exhaust gases back through the inlet manifold, more air will come in, therefore more oxygen. See, the CO2 has actually dropped and the NOx has gone up. HC's gone down a little bit, but it's still a bit on the high side. And you can see the CO level has gone right down. Basically, we're not mixing any exhaust gas in the burn, so we're probably getting a cleaner burn. So, next, let's have a look at see what the engine's ECU says it is doing with the EGR. And of course, we need to remember when we're looking at component data, particularly EGR percentage, that's what the ECU says it is doing with the EGR. It doesn't necessarily mean the EGR is open by that amount, particularly if other components in the circuitry have got a problem. We look at this code reader, we have EGR, engine speed, coolant temperature and diesel pressure displayed on the screen. The EGR in this case is saying around about 88 to 90%. What I now want to do is prove that that is the case. I can do that with a vacuum gauge to see if there is definitely vacuum getting to the EGR, and therefore that should be opening the EGR. There are other things I can do as well. If I pull off the vacuum pipe briefly from this EGR, I should hear a nice clean click as the EGR shuts. Now what I'm going to do is check using a vacuum gauge the actual vacuum being delivered to the EGR valve against the value given on the code reader. We see here 99% on the code reader, near enough at 100%. So we should have a good vacuum being delivered. We have a reasonable vacuum. It could do with being a little bit stronger than that actually. So maybe we need to check a couple of vacuum pipes. But what I now want to do is give the engine a rev and see what happens with the output from the ECU reference to the actual vacuum. If one changes, so should the other. As you saw, the EGR percentage changed, and at the same time the vacuum went off and then came back. That's exactly what I would hope to see. I have now proved that the ECU and the vacuum control solenoid are working correctly. Now let's have a look at the EGR valve itself. Another quick check that can be done is with a multimeter, or indeed a scope. Looking at the mass airflow sensor, what I've done is I've picked up on the signal wire. Now my code reader, my gas analyzer, are all telling me the EGR is at the moment open. And we can see here a signal of about 1.8 volts from the mass air. If I close the EGR by forcing it closed either by the use of a scan tool or by, in this case, pulling off the vacuum pipe, that reading should go up, because that would indicate no exhaust gas being recycled, more air coming through. You will also hear, every time I do that, a slight change in the engine note. If you were able to hear the engine clearly, you would actually hear when I close the EGR valve, the engine gets harsher. When I open the EGR valve, the engine actually gets softer. That's it, pipe off, and the reading's gone up. 2.3. Put the pipe back on. Back down it goes. So, hopefully what we've proved is that you really do need to have more than one way of testing a circuit, just to prove your diagnostics. Of course, you wouldn't necessarily use every single method. We haven't today. We haven't used actuator driving to prove anything, because we didn't need to. But there are some systems where you absolutely have to do that, because they're not vacuum operated, for instance. Electronically operated EGRs, found on many modern vehicles, you would have to use a code reader to be able to drive the actuators. Some systems even permit you to drive the EGR with the engine running. So combination of code reader driving the EGR and a gas analyzer to see the result could be all you need. Or of course a combination of code reader and voltmeter. By combining several different methods, you are proving a problem exists, or more importantly perhaps, doesn't exist. We know with this engine, from what we've seen, there is a problem, but it's a fueling problem and not EGR.